Good morning to everyone. I'm Dr. Sumi MS. The name of the course is Electromagnetic Fields and today's lecture topic is Faraday's law and displacement current. On completion, the students will be able to understand and state Faraday's law of electromagnetic induction and also define what is displacement current. Faraday's law of electromagnetic induction. Michael Faraday in 1831 discovered experimentally that a current was induced in a conducting loop when the magnetic flux linking the loop is getting changed. Faraday's law describes the magnitude of the electromotive force or the voltage that is induced in a conductor due to electromagnetic induction, that is due to changing magnetic fields. It states that the induced electromotive force in a conducting circuit is proportional to the rate of change of the magnetic flux linkage within the circuit. For a change of magnetic flux for a respective unit time del t, the average electromotive force is given as n times del pi by del t, where del pi is the change in magnetic flux and del t is unit time and n is the number of turns in the conducting circuit if it is a coil. An EMF is induced in a conductor whenever the magnetic flux linkage through the conductor is getting changed. Faraday's law states that the magnitude of the induced EMF in a conductor is directly proportional to the rate of change of magnetic flux linkage. Therefore, we can tell for a change in magnetic flux for a time period del t applies only when the rate of change of magnetic flux linkage is constant over the particular time period del t. The direction of the induced EMF can be determined by using Lenz's law. Displacement current. Displacement current is the current that is produced by the rate of change of the electric displacement field. It differs from the normal current, which is called as the conduction current, that is produced by the motion of the electric field. And displacement current is the quantity which is expressed in Maxwell's equation. It is also measured using ampere. Displacement currents are produced by a time varying electric field rather than moving charges, which in the case of conduction current. Electricity and magnetism are related to each other. Hence, we shall consider that the electric current that is traveling through a wire can create magnetic fields around the wire. This type of current is called the conduction current, which is created by the movement of electrons through a conductor such as electrical wire. Whereas in the case of displacement current, it is a type of current that is linked with Maxwell's equation and it is produced by a time varying electric field. Definition. A physical quantity that is related to Maxwell's equation has the property of electric current and it is termed to be as the displacement current. Displacement current is defined as the rate of change of the electric displacement field. Maxwell's equation includes displacement current that proves the Ampere circuit law and the unit of displacement current is ampere. Current in a conductor. Current in a capacitor. A charging capacitor has no conduction of charge, but the charge accumulation in the capacitor changes the electric field link with the capacitor that in turn produces the current called as the displacement current. It is given as ID is equal to JD into S, where S is the area of the capacitor plate and ID is the displacement current and JD is the displacement current density. And here we can relate ID as S times dou D by dt, where D is the electric field. It's related to electric field as D is equal to epsilon E, where epsilon is the permittivity of the material between the plates in the capacitor. Displacement current equation. Maxwell's equation defines the displacement current which has the same unit as that of the electric current and it is given as del cross H is equal to J plus JD, and here H is related to the magnetic field B as B is equal to mu H, where mu is the permeability of the material between the plates and J is the conducting current density and JD is the displacement current density. And using Gauss law we can obtain del dot D is equal to rho, where rho is the electric charge density and thus the displacement current density equation can be written as JD is equal to dou D by dou T. Characteristics of displacement current. In an electric circuit, there are two types of current, that are the conduction current and the other one is the displacement current. Various characteristics of displacement current are as below. Displacement current does not appear from the actual movement of electric charge, which is in the case of a conduction current, but it is produced by the time changing electric field. And also we can define displacement current as a vector quantity. Electromagnetic waves propagate with the help of the displacement current as it has direction. Quiz questions on Faraday's law and displacement current. Give a note on Faraday's law of electromagnetic induction. What do you mean by displacement current? Write down the characteristics of displacement current. Thank you.